In our seventh question, we have this interesting thing where there are two anthropology students and they're calculating the relationship between the length f of the femur and the height h of a female adult using fossilized bones. So what is exactly happening here? What is femur? From Wikipedia, we can see that the femur is the thigh bone, which is this particular bone. So what is happening is, in our question, there are fossilized bones, and these anthropologists try to study the nature of humans and their societies as they were evolving. So here we have fossilized bones, and suppose we have the femur of what we know to be a female adult, then we are estimating the height of that female adult from the length of the femur bone, from the thigh bone. So it is given that this relationship is linear. We have h is equal to mf plus n. Both use the data given below. So this is the data that's available. We have the femur length and the height of the adult female. So from this, we are trying to develop this model. And Chetan has found m to be equal to 2 and n to be equal to 72, whereas Raju has calculated m to be 2.1 and n to be 72. So both of them agree on n. This parameter is already fixed. It is the m that we are trying to see whose m is better. So in terms of linear equation, m is basically the slope of the line. So how do we do this? We want to use the concept of sum squared error, which we call SSE. So in both cases, we are going to look at what is being predicted in terms of height and what is the actual data. So let's look at case 1. Let's look at Chetan's case here and Raju's case here. In terms of Chetan's case, we would have the h is mf plus n, where m is 2. So we have 2f plus 72 minus the actual h, the whole square, and we sum it over how many items? 1, 2, 3, 4. So let's call this fi, hi, and I goes from 1 to 4. And in case of Raju's measurements, this error would be again I goes from 1 to 4, and we have 2.1 fi plus 72 minus hi, the whole square. So I think we just need to do the calculations now. So let's look at this here. So this is case 1. So this is case 2, this is case 3, this is case 4. F1 is 38 and H1 is 147. So when we put in 38 here, we get 2 times 38 is 76 plus 72 minus 147, the whole square. And then in case 2, we have 40 and 150 as F2 and H2. So we'll get 80 plus 72 minus 150, the whole square. And then we have F3 is 42 and H3 is 155. We have 84 plus 72 minus 155, the whole square. And lastly, we have F4 is 44 and H4 is 160. So we have 88 plus 72 minus 160, the whole square. So this is the total sum squared error for Chetan. Whereas in case of Raju, we would get 2.1 times the same thing. So 2.1 times 38 is 79 0.8 plus 72 minus 147 the whole square. And in case 2, we get 84 plus 72 minus 150 the whole square, plus in case 3 we get 88.2 plus 72 minus 155 the whole square, and lastly in case 4 we have 92.4 plus 72 minus 160 the whole square. If we calculate these values, then we get 1 square plus 2 square plus 1 square plus 0 square. So this is 6. So sum square error for Chetan is 6. Whereas in Raju's case, we would have 4.8 square plus 6 square plus 5.2 square plus 4.4 square. Now clearly in this error there is a 6 square which has to be greater than 6, which means Raju's error is much more than Chetan's error. Therefore, Chetan's line fit is better.